Hello all. Today I would be discussing how do we use word embeddings, what are these word embeddings in the context of natural language processing. So when we talk about word embeddings, basically word embeddings are one type of representation of words. When we talk about natural language processing, we often deal with sentences, the language, human language in the form of text as a sentence or as a paragraph, right? So splitting this particular paragraph into some words and giving some meaningful description to that particular word is all about word embeddings. So word embeddings actually is one of the most important concept in the present NLP, wherein each word embeddings represent one particular representation of the word in the given sentence. Basically, we will be using continuous vector space where these words are given some position which also captures some semantic relationships, not just positioning some numbers, right? Not just positioning the numbers randomly, but depending upon the semantic relationship between the words, we position the words or we give some representation to the words. Okay, so in simpler terms, as you can see, word embeddings are simple neural or numerical representation of words that will allow the computer to understand their meanings and relationship other words. Okay, please make note of that point. When you are giving the word embeddings, there are two things that you have to consider. One thing is giving some numerical representation to each word, keeping what? Keeping some meaning to each word as well as the relationship between that word and other words. We will see them with examples. Okay, now let us check this example. In the eyes of computer, suppose I have three words. I have cat, dog and pizza. Okay, when I consider these three words, in the eyes of computer, cat is no closer to dog than it is to pizza, right? So all three of them are different. Okay, so when I encounter such words, so one of the way to deal with this discrete, I consider these three words as discrete because all three of them are not related to each other. But when I come into the meaning or some semantic relation between them, I consider dogs and cats belong to animals. Okay, so we assign individual values to each of these words. Okay, as you can see here, we have simply gone for alphabetical notation. First is cat, dog and then pizza. So we have given three indices values. One is 1 for cat, 2 for dog and 3 for pizza. Okay, now these entire finite set of words that one an application or this task, the task of dealing with these assignment is basically called as vocabulary. Okay, so vocabulary is all about assigning some indices to the words given in that particular sentence. Okay, now as we can see in this previous example, we have just given the numerical representation for each of the words. Okay, so that doesn't mean that you can perform some arithmetical calculations and say 1 plus 2 is equal to 3 and cat plus dog is equal to pizza. Okay, you can't go for numerical operations on the indices that we give here. Okay, so the other way, if you want to give the relation, when you go for this particular thing, we might just go with the random assignment of the indices value, but there is no meaning of the relation between the words. Okay, so if you want to give the meaningful relation between the words, we go for this. Okay, this is called as numerical scale representation, wherein as you can see here, this is one step forward, wherein cat and dog are near, whereas pizza is far away from that, saying that cat and dog belong to some category. Okay, that is animal category, hence they have some mutual relation. Okay, so they are placed together, whereas pizza comes under food category, which is totally different from the other two. Okay, so we can represent the fact that cat and dog are more similar to each other than to pizza. Okay, now when you see pizza is again slightly closer to dog than to cat. What is the need for putting pizza near to dog? Why not cat here instead of that? Okay, so here also we have some discrepancy. Hence, we go for the next notation where we go for this is one dimension. The previous one we have seen is one dimension, which is not giving some meaningful insights about the relation between three words. Hence, we go for this next notation adding another dimension as shown in the figure. Okay. Now as you can see here, what I have done, I have placed pizza somewhere which is equal to almost cat and dog. Okay. So this was limiting in the previous thing. So that is the reason I have added one more dimension called y-axis. Previously I had only x-axis, now I have added one more dimension called y-axis. Okay. Now this is also better, this is also much better, but computers are really good at understanding multi-dimensional spaces. Okay. Instead of just one dimension or two dimension, why don't we go for 3D space where you can represent those words. Okay. Now this is another example where I am representing cat, dog and pizza with some values in the 3D space. Okay. Now when you do this particular thing, the exact meaning of cat, dog and pizza along with the relation between each one of them can be clearly explained. Okay. Now this is how I illustrate that in the 3D space. Okay. So the x-axis, the first element here represents some concept of animalness, that is dog and pizza, sorry, dog and cat, and then the z-axis, that is the third dimension, here corresponds to the foodness. Okay. This is essentially what word embeddings are. Okay. Not just numerical representation, not just one dimension or two dimension. In 3D space, the meaning and the relation between the words can be understood by the computer if you represent them in 3D space, and that is all about word embeddings. We do this in word, this is the concept behind word embeddings. Okay. Now here when you think of multi-dimensional space that has many dimensions as there are words. Okay. Now here what we do here is, for cat in the first position I put 1, for dog in the second position I put 1, for pizza in the third position I put 1. That is, as you can notice here, each vector has only 1 at the position of the corresponding word index. Okay. Now this special vectors are called as one hot vectors. Okay. So vocabulary is something that you have to understand, and one hot vectors is another concept that you have to understand. Okay. Now what is the need for word embeddings? Okay, to reduce the dimensionality. I am not satisfied with the relation when I to go for one dimension or two dimension. So to satisfy the dimensionality requirements and making meaningful relation for the sentence, I go for word embeddings, and to use a word to predict the words around it. Right? When you are depicting the relation between the words, we will also depict the next word depending upon the words around it. Okay. For that reason also we use word embeddings. Inter-word semantics also must be captured. Okay. When you want to make meaningful sentences, or if you want to make computer understand the meaning of the word in the given sentence, like we have seen telescope example, right, bat example. So if you want to make your computer understand the semantic meaning also in that particular given sentence, we will be making use of word embeddings. Okay. Now how are word embeddings used? Okay. Basically, as I told you in the beginning classes as well, we go with the NLP applications by using machine learning and deep learning models depending upon their complexity, right. Now word embeddings are used as input to machine learning models, because the algorithms that I use are machine learning or deep learning models. So we take the words, give the numeric representation and use them in the training or inference. Okay, take the words as input, give the representation and use them in the training. Okay, to represent or visualize any underlying pattern of usage in the corpus. What is corpus? The text data that we give for NLP is corpus, right? So that was used to train them. Basically for training we use word embeddings. Okay. Now there are multiple ways to generate word representation. How do we do word embeddings? Okay, there are numerous ways of performing word embeddings. Okay, that we will see in chapter 2 or unit 2. But before that, let us understand some basic insights of this before I close this session. Okay. Now as you can see, one basic methods or one simple standard method of word representation is one hot encoding. We have already followed this in machine learning, but in the context of textual data, but in context of tabular data in machine learning. But when you go for natural language processing in context of human language, also we will be using one hot encoding. Okay. Now the dimensionality of the embedding is equal to the size of the vocabulary. How many, the dimensionality here, when I take a sentence here, as you can see, word embedding represents a word as numerical data. Okay. So the dimensionality here is 7. Okay. So depending upon that, I take the size of the vocabulary. Okay. Where each and every element of the vector corresponds to that particular word in the vocabulary. Okay. As you can see here, word embedding represents A as numerical data. Okay, as you can see, word occupies the first place, the embedding is the second place, represents third place. Okay, this is similar to what we have done in our machine learning one-hot encoding. Okay, so this is one method of doing your word representations, that is the word embeddings. Okay, so with the development of neural networks, not just for machine learning models, but with the development of neural networks, many advanced methods are generated for these word representations, such as we have TF, IDF, term frequency and inverse document frequency, word to vector, glove, etc. These are few methods with which we will be performing word embeddings that we will be looking into them in detail in unit 2. Okay. Now here are some examples of word embeddings and their applications. Okay. So word similarity, when you want to capture similarity between words, okay, again we go for word embeddings. For example, when you look into the two words king and queen, okay, so king and queen belong to some category called as royalty, right. So both of them belong to that class, so they have some meaningful sentence. So in order to find out this word similarity, we go for word embeddings. Word analogies, like if you want to know king is to queen as a man is to woman, to understand that man is a king, queen is a woman. Okay, for that also we need to understand the relation between king, queen, or king and a man, queen and a woman. Also we need word embeddings in the 3D space. Okay, sentiment analysis, if you want to know if the word, the given sentiment or review is positive or negative, you have to understand the words and the way the word is given in the sentence, that is meaning of that particular word in the sentence. Okay, name entity recognition, as I told you, when you want to identify entities in the given sentence, okay, we need contextual information about the words. Okay, so this is another application. Machine translation, for language translation also you need continuous space and understand the meanings of the words in the given sentence. And then clustering, classification, many such applications where you deal with NLP task. Basically the NLP task, we require, for any NLP task you require the meaning of the word in the given sentence, that is semantic relation between the words. So this is done by word embeddings. Okay, so this is all about word embeddings. We will study about the detailed understanding of word embeddings in unit 2. Thank you.